Hello everyone, Dan Groninger here with another installment in our instructional video series for the USM Go, DMS Go. So today we're going to take a look at using the Top Coat 560, the TC 560 probe, to take through coating measurements. We'll look at how to calibrate the instrument, we'll look at the items involved, we'll step through a calibration, and we'll do some sample measurements using coatings of various thicknesses. So I have a couple of very important things here, items here. First of all is the top coat probe itself. You want to use caution when connecting this to the instrument. You want to make sure you come to probe and select the TC560 probe before you make the connection. The probe uses a multiplexer internally, so connecting it, especially if you happen to have a combined USM Go and DMS Go, if you would happen to connect it in the flaw detector mode with a high energy pulsar, you could do some damage to the probe. So always make sure to be in DMS Go mode, come into probe selections, and pick the TC560 probe before you make the connection. A couple of other items that you're going to need to do the calibration. Your DMS Go will have the zero block, the zero reference block built into the kickstand. We'll look at how to set up the parameters in the instrument to match that block in a second. Also, with your advanced DMS Go or with the available separately, there's a copper calibration block for calibrating the TC560 probe. This is very important. It's a second reference point for material with a different velocity than your material under test. All right. So it's very important that the values of the zero block and the velocity reference block be entered into the instrument before you do the calibration, or the calibration will not be accurate. So if you go to the Home menu, navigate to the Configuration menu, and scroll up on the Config menu, there are two parameters here, zero block and velocity reference block. All right, and you need to make sure that the parameters under the zero block and the velocity reference block have been entered accurately for the blocks that you physically have. Okay, so if we go into the zero block, notice I used a right arrow or right movement on the zero block to open this editing panel. So in here I can look at thickness and velocity. So if you look carefully on the zero block itself, you will see engraved on the block the thickness. In this case, it's 6.338 millimeters and a velocity of 5718 meters per second. We always mark the blocks only in metric. You'll notice that the menu, the parameters in here for setup for entering those are fixed in metric. In this case, 6.338 matches. So if I wanted to make a change up and down to select the item, right and left to adjust the values. Okay, those are correct, so I hit done. Come down to the velocity reference block. Again, I use the right arrow. Okay, in here, I can choose whether I want to work in inch or metric. The serial number is engraved on one edge of the block. On the other edge of the block is engraved the velocity, and in both inches per microsecond and meters per second. So the velocity is expressed there in two ways, and the serial number on the other side. If I wanted to change the serial number, I can enter in here. I've got a virtual keypad. When I'm done, I hit enter. With the velocity, that's changed just like before. So up and down to select, right and left to change the value. And coating velocity is something that you would need to know as a parameter of the paint or coating or epoxy that you expect to encounter when making your measurements. So that needs to be a known quantity that you would enter there. When you've completed setting up the velocity reference block, click the Done key. And at this point, we are ready to connect our probe. So we plug in, making sure to observe the keying on the connector. Go ahead and connect our probe. Go back to the Probe and Cal menu. Scroll up to Calibration. And now put a drop of couplant on our blocks. I also have a standard 5-step calibration block here. Put a drop on my 1/2-inch step. Okay. So at this point, we're ready to begin our calibration. So on the Probe and Cal menu, we scroll to Calibration, right arrow to start. So the first instruction is to put the probe on the 0 block. That's one built into the kickstand using couplant. Stay coupled. Remove the probe. Okay. Now it's time to go to the velocity reference block. That's the copper block. Couple up. Complete. Okay, now it says go to my standard calibration block. So I go to my 5-step block, go on the 1/2-inch, and I've completed the calibration. So now you'll notice my display is showing me both thickness and a coating thickness. So the smaller number is the coating thickness, big number is the material thickness. Now you may notice a little bit of variation in coating and thickness as we squeeze couplant out from between the block and the probe. I have some plastic shims here of varying thicknesses. My red shim is 1/2 inch, or 2/1000. So if I put that on the 1/2-inch block, and I've got a little bit of variation from couplant and squeeze out and so on, but 1/2-inch, 3/1000 thickness. Pink shim is 15/1000. I'm showing up just a little bit thick on the coating. I'm showing 16/1000 and $4.99. Go back to, so I'm off by about 1/1000, which is within the tolerance of the instrument. I believe my blue shim is 5/1000. Yeah, so $4.99, 6/1000. Give a little couplant here. We'll try the 300,000 step, and 5/1000 and $2.99. So pretty well right on the money. And that is the top coat feature with the DMS Go. So again, this is Dan Groninger for GE Inspection Technologies, and thank you for joining me today.